Hello guys, welcome back to my channel Code with Anish. So today we will learn how to create a web application monitoring system. So first, what is web application monitoring or application monitoring? So basically it is a tool or a system that tracks the availability and usage of any applications and ensure that the application performs all the processes as expected. So in our software field, we are providing applications to many companies which will be running 24/7 and which will be serving purpose for their business, which will be doing a lot of business logics and business rules which are needed for that business to run smoothly. So this application monitoring system, so what it will make sure is it will make that the application is available and ensure what it is intended to do, that it is performing correctly. So how it make sure, how this application monitoring system makes sure that the applications which it is intended to monitor is performing all its processes as expected. So it's really based on some real-time checks that is based on some metrics, performance metrics. So performance metrics like the CPU usage, the memory usage, whether the APIs are called successfully, whether the request latency is good enough, or it is taking too much time for an API to process. So this kind of metrics will be used by this system to monitor it. Okay, so by doing this, it prevents the downtime and other potential problems with the business critical applications. So any application for a business is critical only for them. So if the application went down, even for a 5 minutes outage will be creating a huge loss for business. So this with this help of monitoring system, the business and its technical team make sure that it is always up, there is no downtime. If downtime is there, this monitoring application will trigger an alarm and alerts and all, and make sure the team acts quickly and resolve it. So this is an overview of application monitoring. So why is it important? So issue detection and resolution, this is very important, right? As I told, for example, consider an application like Uber, the taxi aggregator app. When the user tries to book a taxi, it's not booking, even though they are seeing taxi nearby, but the booking is not happening. So there should be some issue, correct? Due to actually they are not even unable to book. So if there is a proper application monitoring tool for such system, this error, what happened, will be already highlighted to the business team, the business operation team, and then they can raise appropriate ticket and ask the technical team to check it before it is faced by the customer. So as a customer, when we book it, we are facing an issue and then calling them and saying, instead of them, if they have a proper monitoring tool which can monitor and raise an alert accordingly, they can fix it before it is faced by the customer. So that's only issue detection and resolution. Improve performance, same way. Not just Uber, any application when we open, if it's keep on loading, it's not coming, the whatever API we call, means whatever button we clicked, we are not getting a response. This is because the latency, correct, the performance is degraded somewhere. Whatever the API we are calling, it is taking more time. So with this application monitoring, if such things happen, it can raise an alert to the business operation or technical team, and they can look into it then and there. When the alert comes, they will look why this API is taking more. For example, their API response will be 10 milliseconds for some API, but it is taking like 5 seconds, 6 seconds, or 1 minute. So they can act why, what is the issue there. So they can act on time, and before it is faced by the customer, they can fix it there. This may be because of some database issue, database SQL is taking more time. That's only when they are alerted only, they will be coming to know, right, why that API is taking more time, and they can fix it. So with that thing, the performance of the app can be increased. If they act on the time and fix the application, increase the, decrease the latency, the application performs well, and thereby it will not be shown to the customer will not face that, so performance improved. Yeah, so basically if both the above 2 points will result in an improved user satisfaction, and the 2 points are addressed only when we have an application monitoring system. and robust security. Yeah, security is very important. This is because, as you have seen my previous video and all, where I have created video on this authentication application and all. So we protect our applications using the OAuth token or the authorization token. So this token are created only for an authorized user. An authenticated and authorized user will only have a valid token, and that token will be used to call the APIs. But you know, there are hackers who will try to create their own token or somehow try to hit our system to break our security, so that they can intrude into our system and hack the user data and all that. So that will not happen in one shot and all. They will be trying a lot of requests, they have their own algorithm. They will keep on hitting our system to break it. So whenever an unauthorized system hit our unauthorized request hit our system, as you see in our previous video, we will send an valid response like 401, 403 and all. So with this application monitoring tool, we can monitor such requests. If there is a huge inflow of such requests, like which results in 401, 403, then we can act then and there only, because we can, maybe if we see some specific IP only this is coming, we can block that IP, and we can by that way we can stop the flow of that hackers who are trying to hack. Correct. So this can be done only if our system have a monitoring tool which monitor all these cases. That's only. So with this application monitoring, we can attain that also, and thereby the security of system can be increased. That's the last point here. Now, we learned what is an application monitoring and why it is important. So what are types of it? How all we can monitor the application. So performance monitoring, as I told, if an API is taking long time, we can monitor such APIs. So that is performance monitoring. Error monitoring. So whenever we call an API, it results in error. Because we didn't expect an error, but for example, our API is integrated with another third-party API, and that third-party API results in error. A simple thing is sending an SMS. For example, whenever someone call our API, once the API is processed, we have to send an SMS to that user. So we use rely on third-party application, right? But that SMS got failed. So such things and all we can monitor, right? Because until we are not monitoring, we will only come to know such error when the user really complains. Look, I am doing this thing, but it is not working as expected. So that is what the error monitoring, one of the type of application monitoring. Then availability monitoring. Of course, that is very important. Our app should be always 24/7 running. So we can. That is another type where we make sure the application is running 24/7. Log monitoring. Log monitoring is important because whenever such issues the performance issue obviously the business team will ask the technical team, the development team only to check why it is such that. And that thing, for them to do that, they really need a log, correct? Because log only will have all the details, why this is taking this time, why that error has come. So that the log monitoring is one way where we can check the logs and make sure why it is taking this much time or why the error has come. And security monitoring, as I explained earlier, for the security, we can check the request is resulting in 401 or 403 or any error which is not any response which is not desired. So these are the types of application monitoring we will do with our monitoring system. So the tools and software, there are a lot of tools and software available in the market which can be implemented. There are open sources, there are paid versions also. So in this video, I am going to show you some set of tools using which I will show how I monitor my applications. So my application is developed in SpringBoot, a SpringBoot web application. So I will show the tools and software which I use to monitor this SpringBoot application to make sure it is running always, it is having any error, or if there is any latency issue, that all will be monitored, and the log also monitored by this tools and software. So first one is a Prometheus. That is one app software which is also an open source. Then other thing is called Alert Manager, then Loki, and then Grafana. Using these 4 tools combined only, I will create an application monitoring system which will monitor my SpringBoot web application. Okay, so without any delay, I will explain the SpringBoot applications which I created. I will go through the code, and then I will show how to run these applications locally and monitor that SpringBoot application. Okay, so this is the SpringBoot application which I created, for which we need the monitoring. So I named it as SpringBoot app monitoring. So here you can see the pom.xml. It is a Maven project only, so I have the pom. So here you can see, so I have defined the Spring Boot starter parent and the Spring Boot starter web, because this is a web application, so I need this library. So this is the parent one, and this mainly this is enough for our web application to create the endpoints. As suppose the endpoint, this much is enough. Now I add one more Spring Boot library called Actuator. So Actuator is the Spring Boot library which will provide the metrics like the CPU usage, memory usage, and all that. Only if we add this Actuator, it calculates that metric. So that's we need this thing. So after adding Actuator, we need the Prometheus. So only by adding Actuator and a Prometheus only. So Prometheus, this will make sure that whatever the metrics came in this Actuator, it will be converted to the Prometheus understandable format. So Prometheus is an application running there which will call this endpoint, Prometheus endpoint of this web application to get the metrics. But this metrics Prometheus expect in a particular format. So that format will be provided by this Prometheus library. So this Prometheus library and Actuator work together to get the metrics which is understandable by the Prometheus application. And then the Loki. So Loki is also an application, but how? When now what Loki has to? Loki has to collect the logs of this Spring Boot application. So that can be done using this Loki library in our application. So how it works is, after adding the Loki, we have to come back to our resource folder, and we have to add the logback file. So in this logback file, we have to specify an URL. So this is the URL where Loki system is running in 3110 port. So this Loki, this is a host name. So here it is running and it is listening in this path. So what happened, how it works is, with this library, whenever a log is generated by this our Spring Boot application, it pushes to this URL, and once it reaches that URL, the Loki application will store that data. And this is the pattern we are using. So this is how the logs will come there. So this is the label, so we got to filter the logs, and this is the pattern. So the pattern is like the date first, and the the class, the log level, and then like debug or info and all that, then the class name here, and then the message, actual message. So this much thing will be printed here. So that is how logs will be collected. So now we are clear with the Prometheus and the log. So these two things are, because Prometheus is for the collecting the metrics and Loki is for collecting the logs. That's all for the library. And now when we come to the code, so here I just created only a main application, a Spring Boot application, and there I just create only one endpoint. So this is the endpoint of this application. It's a simple dummy service only, just to monitoring purpose. So what all I created is, I have created a user/name endpoint, user/address, user/payment. These three endpoints are there for my web application. And here you can see I have given some parameter based on which I am simulating some scenarios. Like, look, if I want to check the delay, an API should delay, so I am purposefully creating a delay here. Look, if this input comes as true, this API will take time to respond, delay. It will be delayed for 5 seconds. Same way, if this input comes for this request, I am erroring out. Because why I am simulating this? Because for this scenarios and all, I should check that whether our alerts are coming correctly or not. And then another one, address. This is something successful API, just doing nothing, just returning address. Then there is something called a payment. This is something like a critical API I have defined, because payment, for example, whenever we make a payment to any other application, if there is an error, it is really undesirable for us, right? Payment fails. So such API should be a very high priority. That's why I have put a scenario of error, how it is alerting there and all that. So just this three endpoint I have created in the application. That's all. It's a simple application just for monitoring these three endpoints. Now coming to our Docker setup. So this Prometheus, Alert Manager, the Loki and Grafana, I am using the Docker image only to set up locally. So how it will work? So in the Prometheus, if you see, we have two files. One is a Prometheus YAML and another is the alert rules. So in this Prometheus YAML, we should configure like this. First, the important thing is the scrap config. So scrap config is where the Prometheus will listen and collect the metrics. So we have to give the endpoint. So endpoint is what? Actuator.prometheus. So what it really means is, there is an application SpringBoot app 8080. So our application, the SpringBoot application I showed just now, it will run in the port 8080, and its host name is SpringBoot, because in the Docker I have given the host name as SpringBoot app only. So that I specified here. So this application 8080, as I showed with the Actuator and the Prometheus library, it will expose an endpoint like Actuator/Prometheus. So in this URL, this Prometheus application will keep on polling and collecting the request. And how often it is done using this scrap interval. So it means 5 seconds, means every 5 seconds the Prometheus applications, which actually I show you how when I run it, that application will call this endpoint and collect the metrics. So when you call this endpoint, it will give a metrics, and that will be stored by the Prometheus. So this is what Prometheus YAML is doing. And now this is just for the collection purpose. This will not create any alert or anything. This is just for collecting and storing in the Prometheus system. Now, if there is any undesired behavior, we need to create an alert. So for that, we have to give a rules file and provide an alert.yaml. Alert, some meaningful name .yaml file. So that's I am given here. So inside this file only, I will create alerts. Okay, so this is where the alert is coming. And once this alert, I will show you the alert, but what happening is, once if there is any rules mentioned in this alert rule satisfied or invoked, what should we do? We need to trigger the alert manager. So alert manager is another system. So as I told earlier, Prometheus, alert manager, then what? Loki and the Grafana. So if there is any alert rule satisfied, this Prometheus will call the alert manager. Alert manager will be running in the port 9093. That's what does this mean. So this many things, with this configuration, we can make our Prometheus app, and for any alert we can call the alert manager, means Prometheus can call the alert manager. These settings. Now coming to the alert rules. So these are the rules I have created here. So I have created like 1, 2, 3, 4 rules I have created for my application. So the first rule is an API error. So if there is an API error, then what I had to do? I should send an alert with the alert with the severity as measurable, because there is an API error. Just the user, to make user aware, some API error. So how I do is, this is called expression. This expression is nothing. This HTTP server, this and all the metrics, what we receive from Prometheus. So HTTP server request seconds max is the time taken, the max time taken for an API. Okay, in that. So here what I'm saying, I'm just checking that function, and there I'm checking status is not 200, not starting with 2. Remaining like 2, because the success for an API, the successful status is from 200 to 299. Anything other than that is not a successful response. So that's only I'm monitoring. If that API, if any API, that's only this HTTP second max will check for any API. If any API, if the status is not starting with 2, means 200 or like that, and URI not in payment. This is why, because I have specifically given another error for payment. That's only. So I ignore any API, means any endpoint with payment. Other than payment, if there is any API critical, because payment, as I told while explaining that, payment is a critical thing which needs a particular specified alarm or alert. So that I am not checking. This will check for any other API if there is an alert, and greater than 0 means if any response which is other than 200 has come, this function will return a number. So that number, if it is greater than 0, then trigger error. This for is nothing. Once this expression is satisfied, this for, whatever time I specified in this for, will say within what time that alert has to be triggered. So for me 0 second, that because If such any error come, raise, don't wait for the to repeat and all, just raise the alert then and there. That's only for is given as 0 second. If I give 5 second or any other time, even if the error is encountered, it will wait for that much time and then only it will trigger the alert. But since it is an error, I don't want to wait, or my system doesn't want to wait there, just trigger the alert then and there if an error is encountered in our Spring Boot application. That is the first rule. Second rule, as I told, the payment, the same rule, but this time specifically for payment. It's only so 2 alert, because this alert, when if I include this in payment, the user will not be, because they will get a message like this, API error, there is an internal error. They will not be triggered, right? Which API? It is generic. Then generic API means they want to act slowly, but payment means they should act then and then. So only I have created a particular alert here. So when such alert, so same condition, only thing is this is only for payment. This is not like, exclamatory tilde is not like, equal to tilde is like. So it's like payment if that is slash payment, that API is there. If there is greater than 0, any error is there, just raise this alert. Understood? So this is for the error scenario. So if any API error come, this alert will be triggered. If the payment API error come, this alert will be triggered. And high request error rate. So this is like an ratio or the percentage of error. So whenever there is an error, this will be triggered. Now another error, so this is this, sometimes this may be like 1 error or 2, or 1 error or something happens, this has come. But now what I'm saying, our ratio is very high. For example, out of 10 requests received in our system, like 5 are error out. That means 50% of requests is error. This is something which the team should look, right? Because we are expecting a stable system where the error will be there, but it will be like a negligible, like not even 1%, like 0.5 something. That's what means, depending upon the load they receive, that will be there will be a ratio. But if the half of the requests are error, that means the system is not stable. There is something wrong with the system. So this is what this alert will do. So what it will taking is, it will taking a status as 500. 500 means internal error, and dividing for the past 5 minutes. It is taking for the past 5 minutes. It will check for the past 5 minutes how many API respond with 500, which is internal error, divide by sum of total request, which doesn't have any status, which will be total request received. Means it can be 500 or it can be successful. Then it's total divided by 500, it will give the ratio in 100 will give the percentage. And what I'm giving is 5%. If there is greater than, if the error rate percentage is 5, because out of 100 requests, 5 requests are erroring, 6 means greater than 5, 6 requests are erroring out, then this should be triggered. This can be business specific. If business is saying no, 1% error also not tolerable, then we can make it as 1 also. So in my system, in my application, I just want, if there is 5% error ratio, trigger this thing. Okay, and here I am specifying URI not equal to this actuator, because as you have seen, this Prometheus will keep on every 5 seconds to this system. So if I include that also, obviously the error ratio will be reduced, because Prometheus will be always calling the 5 seconds. So I don't want that. I exclude that. I am only checking other valid APIs. That's only I have put in both the total request and in the error request count also I have put URI not equal to actuator. URI not equal to actuator. Okay. So this is for the 5 minutes. We'll take 5 minutes. In the past 5 minutes, what was the percentage? If it is success stable, no issue, no alert will be reduced. So here and all, this HTTP server request second max, this thing I am not put time, because this function HTTP server request second max, this will be like around 3, it will monitor like for the past 3 minutes some aggregation is there. So that's only, it's already, this function already have an over the time metrics, but this HTTP server request count is not over the time. It is just a count. Whenever you call at that instance, it will give the count. So I want the count for the past 5 minutes, but here HTTP request second max is max for past 2 minutes or 3 minutes, that depending upon the Spring Boot application only, there the Prometheus library how it behaves. So it gives a value over the time. It just give at the instant of time, but for alerting and all, we should monitor over the system, right? That's only I have put 5 minutes. For the past 5 minutes, what is error percentage? Here it is like past 3 minutes or 2 minutes, depending upon systems. But we don't want to give again a 5 minute here. It will not accept, because this is a like a what do you say, metrics, but this is like a counter. How many? This is over the time. That's only I haven't put time here. So I will just get a matrix here. Here I have the counter, and using this time 5 minutes I make it as a metric. And now the last alert is for the latency. So here I am saying if it is greater than 2 seconds, that means if any API which is equal to 200, means it is successful status, is taking more than 2 seconds, then the latency is high. As per my application, greater than 2 seconds if an API taking is an performance issue. Application expecting less than 10 millisecond enter. So that's a condition given here. So HTTP request second max, this function actually will give the max time taken by a request over a period of time. Here if it is greater than 2, this any request over the past some period of time has taken more than 2 seconds, latency will be triggered. So these are the 4 alerts which we will test, and to simulate that only, as is shown in the user controller, I have given the this one. I have given this scenario. So this is for the latency testing. So here if I send is delay as true to this request, this will give the response only after 5 seconds. So in such cases I expect an alert of latency there. And if I give error here, look, if this one is error, then it will error out. So in that case I should get an API error alert, not the payment alert. And here this payment error, if I send this is error as true, it will error out. So in that case I should get the payment alert error and latency payment error ratio. And yeah, now with this error for get name and error for payment, if I trigger more error requests compared to the actual successful request, if it is greater than 5%, then I should get that payment error ratio, this high request error rate error. So this 4 error I am with this monitoring tool I will be expecting. Okay, so that's with the Prometheus now. So Prometheus is over. So Prometheus will have the Prometheus configuration and alert rules, and once any of this alert is satisfied, here it will come, it will trigger the alert manager. So now we'll go to the alert manager and see the configuration there. Okay, so this is the alert manager configuration. So here if you see, we have the receiver I have specified. So alert manager is used to send alerts only. So Prometheus will, what do you say, calculate the alert or check the alerts, and once any alert is satisfied, it will call the alert manager. So alert manager job is just only to send the alert. It will not do any other processing. Whatever alert sent by Prometheus to alert manager, it will just send that to the whatever receiver we have specified here. Just a bypasser in between the Prometheus and the actual alert receiver. So here I am using only email configuration because I don't have any other alert mechanism like WebEx and I don't want to do that. I just have an email so that I can show in this video also when how an email come whenever such alert is triggered. Okay, so here we have some configurations like group wait, group interval, repeat interval, and group by. Okay, so what is group wait? So here if you see, these alerts all comes in one group. Look, that name is SpringBoot alert. So now what this alert manager is saying is, whenever for that group, whenever a notification come, how much it has to initially wait. No need of waiting anything. When you receive such alert only, you send it. That's only I have put 0 second. Now group interval, understood. So here I am putting 10 seconds because since already an alert has come, it will wait there and then it will send that. Just 10 seconds only because we received first alert that was sent now. So wait for 10 seconds and send this group next alert. Now repeat interval. Whenever a rule is satisfied, here assume I am getting an API error, this is getting satisfied, and this will keep on every 5 seconds, it will keep on, our Prometheus will keep on polling, right, and evaluate, right, and evaluation is defined here. How long, what interval the rules has to be evaluated is defined in the Prometheus, this one, evaluation interval 5. So then means every 5 seconds the Prometheus will evaluate this alerts, means this expression will be run every 5 seconds. So assume that this is already active and an alert is already sent. So after 5 seconds Prometheus evaluate and again found in the system another API error has come. So now already we have sent an alert. Now I don't want to send that alert again and again, right? Because this is already an active alert. It has been already sent, and since the Prometheus is evaluated 5 seconds and the alert again come, I don't want to send it again. So if that alert is active, wait for at least 1 hour, because I have already sent an alert. For example, payment error has come, I already sent an alert. And if the same alert, if it is active, means this will be active, this, as I told, this will be like 3 minutes or something, this will be active. So in that 3 minutes again the same API error or the payment API error has come. I don't want to send the same error. Wait it. So that's only I kept it as 1 hour. So no, after 3 minutes, once this error is gone, then maybe another 10, after 10 minutes again this error come, this error is no more active, then it will be which logic, this group interval logic only will, it will wait for 10 seconds and send it. But if that alert is active and we are getting it, I will ask to wait for 1 hour. That is the repeat interval. And group by alert name, so we have alert names, right? This, so based on this only it will group it in the alert manager. So this is the configuration for managing the alerts in the alert manager. Now as I told, receiver is email. So I have put the email configuration. So what we need the SMTP host here. So here I will be using my Gmail only. So I will give my Gmail host, the Gmail username, identity will be also username only, and the password, my Gmail password or your password. When you can use your Gmail only. It's not just Gmail. If you have any valid email ID and you know the host, you can give that also. And from and to email ID. So here I will use the same from and same to email ID only, so that I will make sure I send and receive the alert there in my Gmail ID. So that is for the alert. This much configuration is for the alert manager. Now coming to Grafana, it is a visualization tool where we can see this metrics, the logs, and even the alerts also. We can see all this, whatever we have explained here, just to see the visual level. Because whenever, for example, when an alert has come, the user should come to the somewhere to visualize that, right? So they can use this Grafana and come there and see what is the alert, what is the metrics, and if there latency, they can see what is the CPU usage and all that. So Grafana will work based upon data source. So here, as I told, Prometheus is a metrics data source and Loki is the log data source. So that data source we can specify. We can have n number of sources here. So in our system we have only 2 sources, one for the metrics and another for the log. So I am using that. So Prometheus, we use the type as Prometheus, access is proxy, and the URL is Prometheus will listen in 9090. So this also I will show how. So alert manager in 9093, Prometheus in 9090, and Loki is in 3100, and yeah, Loki here itself 3100, and Grafana will listen in 30. So Grafana, this Prometheus, same way Loki also in 310. So it's nothing, it will use this URL to get, because this URL it will give the data. Here Prometheus will give the metrics data which is collected. The SpringBoot actuator will give real-time data. Prometheus will store all that data in its data source or in its system, and when Grafana call this thing, it will give all that data over the time, because it has a history stored there. It will get that, and that will be displayed in the where you say Grafana. Same way 3100, it will collect the logs and display there in the Grafana representation, and the logs will come in this pattern, like date, the log level, debug info and all, and the class name and the message. And this will be the filter we use. We can filter using our app name, which I given a SpringBoot app mounting, or the host name, because we can run the SpringBoot application multiple hosts, right? It's a microservice. I can run any host. Means coming to Kubernetes, it's like multiple ports. So each host name we can filter it so that we can see in which host the issue was created. The level, based on level, if it debug level, we can see this is a filter, and this is the content that we see in the Grafana. So that's for the Grafana. So this much is the configuration for all our application monitoring tools. Now, how we build or how we deploy this tool in our local or run in this tool in our local. So that I'm using the Docker Compose file. So Docker Compose file, so I have 5 services. So first one is a SpringBoot app, the app which we need to monitor, that is SpringBoot application, which I show the source code I have shown here. So this is the first one. Next is the Prometheus, then the Alert Manager, Loki and Grafana system. So all this system we can compose, we can deploy in our local using the Docker Compose. By Docker Compose, it will be deployed in our local Docker system and we can access this system. Okay, so first coming to our Spring Boot application. So Spring Boot application, I have Dockerized it. So I have created a Docker file. So I am using Java runtime 21, and what I am saying is copy this as Spring Boot, means whenever we do the build, a Spring Boot app monitoring jar will be created as specified in the POM. Then in the POM build session I have specified this is a jar file you have to create here. So that jar will be created here, and that jar should be copied in the Docker container. It should be copied in the root folder only. After copying, the command to run in the Docker container is java minus, means normal starting of a Spring Boot application, java minus, so that once you run this Docker file, the Spring Boot application will start running in the Docker container. So that Docker file is specified in the Docker Composer for the Spring Boot app. So when we run this Docker Compose, the first Spring Boot app will run this Docker file, and as specified in the Docker file, it will copy the jar to the local, in the Docker container and start that application. And Spring Boot application start in 8080. So I have provided the port forwarding so that from our local machine also we can connect to the Docker container via 8080. When we connect localhost 8080, it will connect to the Docker container port 8080. And service name is Spring Boot app. So that's only, if you see in beginning in the Prometheus, I have given Spring Boot app.80 because this is the service name or the host name in the Docker container corresponding to our Spring Boot application. And it is an 8080 / actuator / Prometheus will give the Prometheus response. Maybe I will run before, once I start this application, I will show this URL and see how that will come. Okay, so that's for the Spring Boot application. Now coming to Prometheus. So Prometheus, I'm not using, it's an already third-party application. So they have provided the Docker image. So we can just use the image only. We don't need a Docker file and because Spring Boot application is our application. So we have a Docker file to build the image. This Prometheus is a third party, but it's an open source. So they have given the image. So that image name I'm specified here. And the port is 9090 because in the Docker container, this Prometheus will start in 9090. So I am forwarding to our local host also. So from localhost 9090, I can access the Prometheus running in the Docker container. And volumes, this is nothing, as I showed, these two things, the alert rule, this when the Prometheus start in the Docker container, this rules and this configuration files has to be copied to the Docker container. So that's only it's given here. So these files from this system with Prometheus.yaml, Prometheus alert rule will be copied to etc in the Prometheus container, in the Docker container, it should be put in the etc Prometheus folder. That's only I have given here. That's all. So when you compose this thing, Prometheus image will be copied in the Docker container and it will copy these two files, and then once it started, it will start with whatever configuration specified here. Prometheus will working with this configuration. Now the alert manager. So alert manager is nothing where we specified the receiver, the wait when an alert is received, how long to wait for the new alert, how long to wait for the alert, the subsequent alert coming in the same group, and how long to wait for an active alert if it has received again. So that configuration also there. So there also, and alert manager listens in 9093, and this, okay, yeah, here also Prometheus service name is Prometheus only. That's only in the Grafana, if you have seen, just it is like Prometheus 9090. Okay, same way alert manager service name is alert-manager. So that's only in the Prometheus, it is alert-manager 9093. And yeah, so it copies this alert manager.yaml file to so here it will be copied to a folder, and that folder name or the file name is specified as a config.file. Okay, by default I think it looks in etc-alert somewhere like that. If you put that default folder, no need of this config file, but if you put in some other place, you should specify that where the actual config file is there. So not to take risk, I copied this to one folder and I specified here config, and log level is debug, so that we can see the alert manager logs, means whether the logs, if you didn't put a debug, we cannot, if you want to, because it's the first time when we're running, right, to see the alert manager started, or alert manager is sending the email and all, so that's why I have put log level debug. Once it's become stable, you can remove it. This is just the just to show that the logs, whether it is sent or not. So that is here for the alert manager. Then the Loki is listening in 3100 port. Same way, the Loki image is Grafana Loki. It is also open source system. We copy that image, and here also the config file. We didn't do anything. We don't have anything here. We just specified in the server. It is like etc Loki local config YAML. This is given from the Loki system only. We didn't do anything. We just reuse the same file. So that is specified here. That's for the Loki. And finally, coming to the Grafana, where we can see the visualization. That image is also Grafana/Grafana only. Give the latest Grafana image, and Grafana listens in the port 300, and Loki 3100, alert manager 9093, Prometheus 9090, and our application 800. And here the Grafana, whatever we defined here, our data source file, whatever we defined here, that is specified here. That is put in etc Grafana provisioning data, this folder. This is the folder where the Grafana system will check for the data source config. So that's all. These are the Docker Compose we need. So when we run this Docker Compose app, all this image will be downloaded, and for our side, our image will be built, and it will set up in the Docker container. And in the Docker container, once it's up, we can access by using this port forwarding from the local host. Using the port forwarding, we can access the Docker container and can see. Okay, so without any delay, I will spin up that. But before spin up, for our application, we should make sure the SpringBoot app monitoring jar is there or not. It's already there. If it is not there, you can use this one, Maven clean install, and you can run that. Maybe I can run once again and show you. Okay, the build is success, and you can see the jar here. This jar, it's already there, but now doing the build, it again deleted and recreated this jar. So this jar is required because when we run this Docker Compose, this Docker file will copy this jar to the Docker container. So that's simple. So that's all. Now how we will spin up. So spin up is, we have to first run Docker in our system, in our machine. So let me start the Docker engine. Okay, so this is the Docker setup for the Windows. So I have opened the Docker setup, and the engine, you can see Docker is already shut. So in my machine, Docker is running now. So as you can see, there is no image or no container as of now. So now when I spin up the Docker Compose file, how many? 5 images. One for SpringBoot application, another for Prometheus, then for the alert manager, the Loki, and Grafana. These images will be set up here, and one container will be created. Inside that container, all these 5 systems should run. So coming back to our application, we will open the terminal. We will go to this Docker setup folder, and then we'll run the Docker Compose up. Yeah, we'll run this command Docker Compose up, and let's see if all these things come. Okay, so you can see pulling the images, the 4 images. The SpringBoot image is not required, that will be built because that image is built locally. All this thing will be pushed from the Docker hub. Okay, the image is pulled. Now the building is started. So our SpringBoot app has been completed, and yeah, look, all the images are created, all the 5 images are created, and now the system is starting everything. So now if I go to the Docker, I can see the images and the container there. So coming to the image, as I told, 5 images. This is the SpringBoot app, the application image, which we are going to monitor, and other things from the Docker hub, the Prometheus, Loki, Grafana, and all the images has been downloaded. Yeah, so now coming to the container, you can see the Docker container here, and it has got all the 5 systems running here. You have the Loki, the SpringBoot, Prometheus, Grafana, and alert manager. All the 5 systems are running in the Docker container and the corresponding port. Our application 8080, 3100 is the Loki, 300 is the Grafana, 9090 is the Prometheus, and 9093 is the alert manager. So everything is fine, up and running. Maybe I will show this URL first, correct? So let's see in our 8080 actually, because this is what the Prometheus will scrap or poll for every 5 seconds to get the metrics. Okay, so if you can see here, when I call our Spring Boot application, this actual Prometheus endpoints, look, there are some values. Look here, like disk free bytes, disk total bytes, executed. Yeah, these all are the metrics. This is a real time. So if I call after 5 seconds, this data will keep on changing. So this, as I told you, Prometheus will call this thing, and every 5 seconds, whatever response is received here, it will store in its data source. That's how it works. It every 5 seconds it will call. Look, maybe you can see the logs here. Look, every 5 seconds, look, get actuator Prometheus. This keep on calling every 5 seconds. And now I will show you the Grafana UI. So because that is where the visualization, all this monitoring, all these logs, everything will come in the Grafana. So let's open Grafana, and Grafana will be seen in 300. Okay, so when I call localhost 300, it will direct to login page, and here the login, and the first time we have to give admin. That is the default password. So I give, it will ask to change it, but I will skip. I don't want to change. This is just for a demo purpose only. So I have the Grafana opened here. Now look, we can see some options here, and if you come here, you can see metrics, you can see connections, and in the connection you can see something called data source. So look, this is the data source. So as we did in our Grafana configuration, we provided two data sources. One is Loki and another Prometheus. So that is what's shown here. Look, that we can see in this data source. And now if you see the metrics, so metrics also, look, these are the metrics. Look, here the data, so you can collect the data source. Metrics, as I told, we have only one data source, Prometheus. Loki is for the log. So look, you can see the visual representation, right? Whatever Prometheus is collecting every 5 seconds from our Spring Boot application, that is getting displayed here. For example, if you see this one, maybe the memory, JVM memory, allocated memory, look, it is 500 KB per second. The class loaded 9.8 kilobytes. Java buffer memory, look, 128 KB. Java buffer count buffers. HTTP request second sum. All these things we can see here. And whenever they want, anyone, our technical team want to monitor our application, you can come here. He will get in picture. What is the usage here? Maybe I will show you CPU usage also here. Process CPU usage. Look, CPU is very minimal. It's, look, at this time it was like 0.0251. Very minimal, right? Because this is the usage. So like that, now by seeing this, we can see the system is stable. If there is any issue here, this will go up, spike here. Same way Java memory, this will go. Look, now our system is using around 405 MB. This is what our system is currently using. There is anything, it will go above, then we can understand system is the RAM. This is the RAM memory used by our system. It's very high. This is okay. This is preferable because we started with a memory minimum memory of around 256 MB or something. So it's in the range only. Like that, this taken metrics. Now, in addition to that, we can create our own metrics to see it. So first, what we need is to come to the dashboard. We have to create a dashboard, and we have to click add visualization, and in this thing we have to create our visualization. So first I will go with Prometheus. So in this Prometheus, what all I need to create some metrics here. So there you can see the graph, but here there's a lot of options to see, like the time series, the pie chart, table, the bar chart, and all that. So here I use Prometheus only. Now going back here, metrics. So what I want is, like, I want to see the number of requests came here. Okay, so for that I will create an alert like HTTP server request count. So the count is the total request hitting our system. Okay, so now if I run query, so it's already reached 80. This is 80 because our Prometheus is calling every 5 seconds. That's all. It's already reached 80. So this is one thing. So now I can, instead of this thing, I can use other visualization. Something like if I give pie chart also, look here, I can see the two things, or maybe yeah, gauge. So this will give, right? So I have two things here. Here I can provide the label as, instead of label I can give some custom, and not label name, I will give us the URI. Okay, so if I give, yeah, I filtered with the URI. So means /*, it was something, maybe a local host, just that call, there was a one call like that. All the remaining 99 call is for Actuator Prometheus, because this is Prometheus is calling during every 5 seconds. Okay, so we got this. This is something some more much understandable, right? So here I can give the panel title as request count. Okay, so I can give request count, save it. So dashboard name is, I give a SpringBoot app, and now save it. So now if you come here, we will have a dashboard is saved. So now anytime, so we can come to dashboard. I just click the dashboard here. I can see now. Yeah, I will save this also. I will make this bigger also, a little bit bigger, so I can see it here. Okay, so that's how it works. So yeah, save dashboard, save. So now if I come here, I can see this after every time. So once the dashboard is created, the user can come here. So like this is one such example. We can create many, using many metrics, we can create many graphs. We can create another visualization also here. So we have to come here, add visualization. We have to click here so that I can add another visualization here. So select metrics. So again the same thing, only HTTP request count. In that label, what I will do is I will filter with the status, means which all errored one and all that. So here status select value 200. If status is equal to 200, error. So here I will give error request count. And here also I can give the same gauge only. So this is status equal to 200. This is not active. I need active is currently just this one. This is not error. This is success request. Success request, run query. Yeah. So all this 143. Now success, save, save. So now you can see success. So I can bring this down. So this will be the request count. Okay. So I can put here. So this is a success request, or maybe I can edit this success request count or success count. Save. So success count, request count, refresh the dashboard. Look, it's refreshing. We can see that. Anyway, this every 10 seconds it will refresh it by default. But if you want really, you can come and click this refresh thing. You can see the color. So in this thing, what I am seeing is 161. All the requests are successfully. Out of the request are success. Now I will create one more to see the error count also. So that now I will trigger some scenario to see how many error and success. Okay. And okay, so here again I will come here, visualization, and here what matrix is HTTP server. Yeah, so if you're wondering where this is coming from, all these metrics are coming from by calling that actual Prometheus URL from our SpringBoot application only. Our application written that is polled Prometheus by 5 seconds and stored in the Prometheus system, and Grafana fetched that from the Prometheus system. That's how the flow is, from our SpringBoot application to Prometheus, and Prometheus back to Grafana, and from Grafana we can see that. That's no other magic here. So again, HTTP server request second count, and here again status are not like the same thing which we have given here. 100 are not equal to, can give that. success count, error count. Save this, apply. So now it will come here, but now as of now there is no data, that's what it shows. I will put here. So if you see this request counts are here, that all are success, error count is no data. So this is one matrix. Sorry, there is one error has come. Edit it. I want not this time series, I want the gauge only. Apply. Okay, so one error count and remaining all are successful. This is how, and if I refresh it, look, 197. Yeah, so this request count from this URL, it is an error, that's only showing error. This kind of same way you can create multiple matrices here, visualization, you can create multiple matrices. So maybe I can create one more matrix also. So HTTP server request second max, run query. So I have something. Now here what I need is, I will also here filter with custom URI. Okay, and gauge. Okay, so execution time, this is second max execution time, the max execution time it has taken, max execution time, apply. Okay, it's coming here, so I may put here this one. Max, the time taken here is for Prometheus, his max time is this only 876. So this is the max time taken. This is one way. So this here we can create metrics for visualization. Now on saving, now anytime when we come to the save dashboard, save it. Anytime when we come back here, we will see this one, SpringBoot app. I can visualize this. Same way multiple can be created. Now same way, now another dashboard is for the log purpose. So new dashboard, add visualization, this time Loki, so to see the log. Okay, so here Loki label is as I told in that Spring Boot, what is it, the log XML, we have filters, so app, host, level and all. So I can put as app only here and select value Spring Boot app monitoring, that is coming in the log. So here what I have to take is, here instead of time series I have to create the logs here. Okay, now when I run query, look, you can see the logs. These are the logs from the Spring Boot application which is seen here. So now we can save it, and what is the dashboard? Spring Boot log. Also in the panel title I can give app log. So now if I come to the dashboard, I have Spring Boot app. Maybe I can edit this also. Instead of Spring Boot app metrics and Spring Boot app log. So save. So coming to the dashboard, I can see Spring Boot log and Spring Boot metrics. So if I take Spring Boot log, I can make this big also so that you can see the log when I come here only. Or if I want, you can click here and you can give view also. That also would come here. So anything is fine. And here also you can refresh, we want to refresh, you can refresh. And this here the logs will be from up to down. And conventionally in our system, when we see the log, we will go scroll down and see the data. But here the latest log will be on the top. You can see the time like 17:30, 17:29. So you can refresh. So look, so with this Grafana save dashboard, we can see the logs also, we can see the custom metrics which we created. In addition to that, it gives a metrics for all that thing. So visualization will be made easy with the Grafana. And now coming to alerts. So look, now here also alert. So we have this alert. So you can see here. Yeah, data source, I want only the Prometheus. So Prometheus, we have, these are the 4 rules which we created. One is API error, payment error here, and you can see everything is green. As of now, there is no error here. Look, the rules which we specified, severity is major, but here payment error, severity is critical. Here Okay, so the alert is also there. And now what we need to do is, now we need to create a scenarios or simulate a scenario where we get each of these alerts and see if it is working. So to trigger API error, what we have to do? We have to, let me open the code. Yeah, so coming to the code, to trigger an API error, I need to call this get name API with is error is equal to this for true, so that it will create an error. And let's see if, but before that, let's trigger some successful requests. Let's first try all these requests and see if we're getting successful or not. Okay, so for that I will use Postman only. Okay, so coming to the Postman, you can see I have created all these three endpoints: payment, name, address. Okay, so let me call that address first. Okay, so I got the address. So now I call this address. Now I call this name. Okay, there is his delay false, everything is false only. So if I call, I should get the name also, and payment nothing. So here also I should get payment successful. So I call this 3 API. Now let's go and see the metrics if this has come there or not in our metrics. So we come to the dashboard and see Spring. Look, we got the user address, user name, and we should get payment also. Yeah, payment also. Look, there's a 5-second delay because Prometheus collect every 5 seconds only. So that's the delay we are seeing here. So you can see we have the, whenever we call that, we get this. So success count also. Okay, this request count and success, there is no failure. Okay, maybe here I will put a filter also because we doesn't know which is this count. So edit. So I will put this here, option label. We can put custom and we can give URI. So I will know which URI only space. Look, we will get like that. Now save. Okay, so you can see response to this one, all other are successful only, 296. Yeah, there is some delay. If you refresh it, it should be, yeah, 314, 311. Yeah, and look, execution time. Prometheus has taken 0.0, that is the max execution time. Address, look, 0.0681, and username is 0.00632 seconds, and user payment 0.0384 seconds. This way we can, so everything is on time only, means the latency, everything. Now let's see the alert and the metrics also. So before that, let me call this APIs multiple times to increase the success rate. So send. Okay, now let's monitor the metrics and see how the increased. So I call the name, it should increase now. Yeah, look, so 7 success, there is no error as such. Okay, now let's call the error. So is error is equal to true. So now what I expect is when I call this thing, I should get an alert, correct? So let's call send. Look, we got an error, 500 server error. Now let's see the alert, if the alert is raised or not. So we come here, alert. Look, when there was an API error, you can see the alerting rule is firing. Okay, because this is an API error. So like this. And now let's see if the email is generated. So firing means email should generate. Let's see if the email is generated. That's what we have set in the alert manager, right? When an error is there, send an error. So it's firing. Firing means already email should have triggered. Let's see. Look, so this is the error we have got. This is, sorry, the alert we have got. So when there is an error, look, it has sent an email to my email ID because that is what I configured the alert manager. Look, the alert name is API error. The application is app monitoring. Instance is here, SpringBoot 8080. Outcome is server error. Annotation, there is an internal error for the username. Title is equal to API error. Okay, so this thing, this annotation is what we defined in the alert rules. Look, the description, there is an internal error for $labels URI. So whenever we call this expression, it will give some response. That response can be used like this, means which URI it is. We can use $labels.uri to get that URI. That is what is displayed here, user/name, user, and the API error. That is the title. API error, title is API error. So that is working. So this is how. So when such error comes, this as configure the alert manager, the operational business team will get it. So they will understand there is an error. So what all the business solution they have given, they will act on. They may raise a ticket to the technical team, or they will raise some other Slack meeting or something just to configure. So this is this. So our intention is with this application monitoring, something like without manual intervention, we should come to know that there is some error. Okay, now coming back into that. So that alert has sent. Now API error came to normal state. Now the payment API error. To trigger the payment API error, same way we have to call what? We have to simulate the payment API URL with the error. I have to give is error is equal to true for the payment also. So I have to put is error is equal to true. So now when I send it, look, it has written 500 internal server error. So that I should get the alert there also. Yes, so look, so we got the payment API error also. So when the user comes here, he can see, look, at that time when he comes to alert, he saw that this payment API error also is firing. And coming to the email, you can see, we got the mail also, look, payment API error, and there is an internal error for payment. This is what defined in the alert rule. So we got the mail now also. For this also. This is how, look, this is how our monitoring. Now, as you see, when the payment API error, this API error is not triggered. That is how the expression which we defined works. There I have specifically told, if only the API has /payment, trigger this. If this has to be triggered only if the /payment is not there. So this is happened on the endpoint /payment. So that's only this has triggered, this hasn't triggered. So that is the intelligence of the expression which we add, which will trigger the alert accordingly. Okay. So now what? High request error rate. So this is where if we get an error request percentage higher than 5, correct, after total request. So now, so I have created some more payment API error to increase the percentage. So for that, the payment API error is triggered because if there is any error in payment API, it will send alert. But if you see the high request error, it is pending for 2 minutes. Why it is pending for 2 minutes? This is because if you see in the alert rules, this alert will be monitored for 5 minutes. For the past 5 minutes, what is the percentage? So for the past 5 minutes, now it has exceeded that 5% ratio. But once it's exceeded, I have put a for loop. Look, if you see other two rules, we have put for a 0 second only. But here it is 4 minutes. Because why I'm putting 4 minutes is because for the past 5 minutes, we want to observe the past 5 minutes. So in the first 1 minute, I got the ratio as greater than 5%. But in the subsequent 4 minutes, there is a possibility this can come, the increase ratio can come up and the error ratio can go down. So in that case, when I saw itself, if I trigger it, that will not become meaningful. Because my requirement is for the past 5 minutes, the percentage ratio should become greater than 5. So that's why I am putting a wait for 4 minutes. Yeah, look, 4th minutes, now it started firing. Now let's see if we have got the logs. Okay, so we got the error for the high request error rate, alert for the high request error rate also. Look, here the label is high critical and the description is the internal error has reached 100%. And so look, I have sent 100%, means I have triggered so much error, so it is saying 100% in the past 5 minutes. And this description, how it has displayed here is condition. Look, I have given the description as error percentage has reached the value. This value is nothing, whatever this expression evaluated, that will be, that we can obtain as this dollar value. So here, if it is greater than 5%, in our case, it has reached 100%. This value 100% come based upon this only. This humanize will make it as correct readable format, readable value. Otherwise, it will contain some decimal and all that. So to make this 100 and the percentage, you can give like this. Dollar value is what is given here. This dollar label will be like what are like this. These are the labels like URI status and all that. URI status. This we can display here in that. Okay. Anyway, so we got the alert for this thing, high request rate. Now one more alert we need to check, that is for the latency. Okay, so after firing that, the alert has become normal, means the firing is stopped. Now the high request latency, so what we have to do, and again we can check there how many time it will wait there and all. So latency, if the time taken for any API other than Actuator, if it is greater than 2 seconds, wait for 1 minute. So let's take the Postman. is delay equal to true. So I will get a latency there, true, and error is equal to false. So in this case I don't want the error, true. So send. Look, it will wait for the 5 seconds and then only return it. Look, it took 5.01 seconds. So now that alert should be triggered, but it will be pending for 1 minute. Let's check that. Look, alert is triggered, but means alert has come, but it didn't trigger. It will be wait. It will be wait for how much? 1 minute. Look, that's what we defined here. It will wait for 1 minute, and in this 1 minute again it will check. Still that is 2 seconds or it has reduced. The max time has reduced. If it doesn't reduce for this 1 minute, it will trigger it. So we'll wait for that and see. Yep, it waited for 1 minute and it fired it. Now let's see our Gmail and see if it has come or not. Perfect. We got an alert for the high request latency also. So here if you see, the username is having a high latency of, look, 5.0. This is what we received in the response also, right? It took 5 seconds, 5 point some second, and that's what how this message is created. You can see here also I have given this value, because this output of this expression will be printed as $value. So here it become more than 5. That's only 5 is greater than 2 seconds. So I'm putting that, and label UR is, what is this? Is username. So username is having. Okay, so everything is fired. Again the alerts, everything came normal. Now there is no more alert which is in pending or in active state. Active means it is already triggered. No, nothing is there, everything. So okay, so now it's clear, right? Look, with this Grafana we can visualize the alerts, we can visualize the logs. Look, we can see the logs, we can visualize the metrics, custom metrics for our purpose, all metrics here. As from the operation perspective, they can come here and check all the status of the app, the monitoring the app perfectly. And with the alert manager, we received whatever alerts we defined in our system, we received it. With the help of these 4 tools, we are making our app stable, like performance issue, error issue. We are getting trigger alerts so that we can act and fix then and there. So this can be done only if we have this kind of tools. If we don't have an alert manager and our application is running, we will not be aware, because we cannot 24 hours go and check the app and see if and look, millions of requests will come. We cannot see which request has taken 5 seconds or which request has 10 error. Very difficult. But all these things, this tool with the help of this 4 software, the whole system will take care, and we get the accordingly alert and we can act it. Thereby we can make our application strong, and user satisfaction can be increased, performance can be increased, security can be increased. Whatever I defined in the beginning, we can attain all that. So this is the purpose of an application monitoring tool, to make our app bulletproof. Okay, so that's all for today's video. I hope you like this concept of app monitoring, and I will, in the next video I will come with a much more better topic. Till then, take care, bye.